them to linear relationships. So in grade 9, we focus a lot on linear relationships, and we've also talked about linear relationships in this course as well. So a linear relationship is a line. It has a degree of 1. So if you look at the equation y equals mx plus b, it has an exponent of 1. And we know that something is linear if we look at a table of values and the first differences are the same. So with a parabola, we saw that parabolas are quadratic relationships. They are shaped like U's or rainbows, so they can open up like this one here, or they can open down. If we look at a table of values, the second differences in a table of values were the same. And the degree, or the highest exponent of the equation when we looked at it algebraically, was 2. So those were the 3 things that we looked at earlier in the course that told us if something was a parabola or a quadratic relationship. So what we're going to do today is we're going to just focus in and look at some of the different parts of a parabola, so that when we have one of those U-shaped or rainbow-shaped functions to look at, then you can tell me some of the characteristics of it. So the first thing, like I said earlier, actually, is the direction of opening. So parabolas can open 2 ways. They can open up like this one here, or they can open down like this one here. And if we look at this equation right here, or this parabola right here, we see that this one opens up. So the direction of the opening, if I was going to put little arrows here to show that it goes on forever, they would be pointing upwards. The second thing are the zeros. And the 0 is basically another name for an x-intercept. So when you see the term zeros, that means it's asking you, where does the parabola cross the x-axis? So if we look at this x-axis here, I actually see 2 zeros. The parabola will cross the x-axis often in 2 places. So in this, those 2 places will both be points. So in this one here, you can see that this point right here would be -1, 0. So one of the zeros would be -1, 0. And the other 0 would occur right here, which would be 3, 0. So I can write those 2 points down, -1, 0 and 3, 0, as my points of my parabola. Along the same lines, we have our y-intercept. And we talked about y-intercepts with lines, and we also have y-intercepts with parabolas. And the y-intercept is where the parabola hits the y-axis, so looking up and down. In this case, for this parabola here, the y-intercept occurs right here where it crosses the y-axis. And if I were to put the coordinates to that point, it would be 0, -3. So the y-intercept would be 0, -3. So that's what I'm going to write there, write it as a point. And you'll notice this is really important. Every time I write a point, I always write it with a comma between my x-coordinate first and my y-coordinate second. And I always put brackets around so that the reader knows I'm actually talking about a point. So that's really important in terms of the communication of how we write points. Okay. The vertex, this will be a new word for you, but it comes up often when we're talking about quadratic relationships or parabolas. The vertex is the highest or the lowest point of the parabola. So if I look here, it's going down, 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 down. It hits this point here, which is the vertex, and then it starts to go up, 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 up. So the vertex is right here where it switches from going down to going up. It's the lowest part of this particular parabola. And again, it's a point. So if I'm looking at this point, I'm going to go across 1 on the x, and I'm going to go down 4 on the y. So the point, this vertex, would be 1, -4. So I'm going to write that down with brackets around it under or beside my vertex. Now the axis of symmetry is almost like a fold line. So if I was to take this parabola, which is perfectly symmetrical, if I was to fold it in half, the fold line would be along the line x equals 1. So I draw a dotted line down here. It's a vertical line, so it's in the form x equals, and it's x equals 1. So I'm going to write that x equals 1 as my line of symmetry. And the last characteristic I wanted to mention to you is either the maximum or minimum value. So that's when we're looking kind of up and down, and I want to see, well, if I look up, this is going to continue going on forever and ever and ever up. So infinity would be my highest value. But if I look going down, there's actually a lowest point. The lowest point occurs at the vertex. So the lowest y value on this parabola would be the -4. It's going to be the y value of that vertex. So in this case, I have a minimum point or a minimum value, and that minimum value is -4. And actually, it's kind of neat if you can figure out what the vertex is. So if I know that the vertex is 1, -4, Then my axis of symmetry is always going to be my x value of my vertex, because it will always cut the parabola in half down the x value of that vertex. So you can see the point has an x coordinate of 1, and the axis of symmetry is also 1. And along the same lines, the minimum or maximum point will always be the y value of the vertex. So you can see that the lowest y value on this parabola occurs at the vertex at -4. So that's going to be my minimum value at -4. So the vertex actually contains information about both the axis of symmetry and the minimum and maximum value. So those are the characteristics that I would like you to be able to point out when you're looking at a parabola. Knowing these things can help you actually discover a lot of things about the parabola. It can also help you anchor a picture of a parabola. So if you have an equation and you want to be able to sketch the parabola that it's modeling, if you can figure out what the zeros are and the vertex and the y-intercept, that's actually going to give you a lot of information about what the parabola looks like. And when we do models later on, these will be the key things that help you decide what the models will look like and what the models are telling you. So some key characteristics of parabolas that I would like you to practice working on today.